Hey everyone, sorry about the delay. My name is Venkatesh. I'll be the host of the session today. On behalf of SkillLink, I welcome everybody. For those of you engaging with SkillLink for the first time, we are an engineering upskilling platform focused on advanced technologies across mechanical, electrical, electronics, and computer science. Our enterprise business focuses on employee training and upskilling across industries, including automotive, consumer electronics, ITES, across various verticals. Today's webinar is on harnessing IoT for automotive applications. This is the 19th edition of our webinar for corporate professionals. Before we start the session, couple of pointers for everybody. We welcome you guys to post your questions on the chat window. We'll take up the questions during the interactive session part at the end of the session. We'll also share a feedback form on the chat window. Please do spare a minute to fill this up towards the end of the session. We'll not be able to share the deck. However, the recording of this session will be uploaded on YouTube and you will get a link to it. So about today's instructor, Mr. Rohit. Mr. Rohit is an embedded systems expert with over 24 years of experience across smart home, smart city, and automotive domains. He has led multiple IoT projects as technical director, CTO, and consultant, making him a leading voice in IoT innovation. We are excited to host and hear from you, Mr. Rohit. Over to you.
Thank you, Venkatesh, for the introduction. So I hope everybody is able to see my screen. So today I welcome all of you. Good afternoon. We'll be exploring what IoT has made to today's automotive domain. So all that we have been talking about our IoT, we'll cover those topics in the session of 1 hour and 15 minutes. A short intro about me. So I'm going to skip the slide. Yeah, so in today's session, I'm going to cover talking right from what IoT is about, how it evolved, and how it has completely changed the landscape of today's IoT market, both for the consumer as well as for the manufacturer. So we're going to explore on that front. We'll also be talking about what are the key technology factors, connectivity protocols, and all the underlying technology that today has changed automotive company from moving from a pure mechanics and electronics to a software-driven approach. We'll be exploring some real-world applications. We'll take a look at where and all IoT is playing an important role in the automotive sector. We'll also talk about challenges and opportunities in this domain. And we'll also go through some of the case studies and industry insights to know where these technology has been making an important forefront. And also we'll take up some lessons that we learned from the past mistakes, where I'll cover some of the topics on what really happened in terms of security loopholes, in terms of hacking in automotive space. And finally, we'll have the Q&A session. So I believe from the audience that we have, all of you have some knowledge about what IoT is. What the acronym is basically Internet of Things. So before I really get into what these 4 different IoT types are, I just want to go back in memory, say around 15 years ago, when cell communication was a new technology around, where there was not much about data that we talk as on date, but it was more about cellular SMS communication. So that was this company called Hutchinson, which I have been working with them and automating their gensets, especially for all the remote cell towers, which needed some sort of a backup power. So if the main power would go off, the generators would kick in and they would power up the units. One of the significant problem in these sort of use cases was somebody had to manage switching on the tower on time. Somebody had to manage the diesel consumption so that there are no diesel thefts, and those sort of parameters had to be monitored. So what we are talking of IoT today has already been in existence right from those days, but it was more on cellular SMS messaging, and where SMS alerts would be sent when something happens to the device. Using SMS, we would activate the controls of the system. The same technology today has gone through such a rapid change, and today we are talking about the same technology, but with more enhanced capabilities of decision making, processing power, and so on. And that's where these 4 sectors of IoT come in place: the infrastructure IoT, industrial IoT, commercial, and the consumer IoT. And today we are going to explore the automotive IoT, which comes under the commercial and consumer. I'll tell you why I have put it in between these two. But infrastructure IoT is all about smart cities, smart street lamps, traffic lights, and so on, where an infrastructure is automated for decision making and with some sort of an intelligence. When it comes to, say, the industrial IoT, it's all about robotics, say robot welding. And if you look at the automotive industry, it's about welding the joints with precise locations, with the precise weld temperatures. Also, there are vibration sensors, and all of these things happen in the industrial IoT. Commercial IoT is again where you have automatic robots which manage the warehouse. Or if you take a look at, say, the ports, the shipping and port business, where you have a lot of containers coming and going out, automating the container movement, making optimal route plannings to stock these containers. So those all fall under the commercial IoT segment. And the consumer IoT is all about the smart robots, the vacuum cleaners, maybe say the smart perfume odorizers, and all these things fall under the consumer IoT. Automotive IoT in specific falls somewhere in between the commercial and the consumer IoT. The reason because it has to be as robust as a commercial IoT segment in terms of the harsh temperatures which the automotive offerings have to sustain. But at the same time, there's a very uniqueness to the automotive in terms of consumer touch. A lot of things you would do on your phone today can be done on the car's dashboard. And those are things where there is some merge between the consumer IoT and the commercial IoT segment. So if we talk about the basic goals, why are we trying to do a lot of these IoTs? Why is this so getting popular? Is because we want to make technology affordable and easily accessible. Which means there's a lot of connectivity happening. There's a lot of market segments which tap the technology to make it unique. And there's also some sort of connectivity between device, between the infra, between these vehicles, and so on. There's also requirement for reliability. There's a continuous flow of information that is needed so that you could do something with the data, apply intelligence to it, and automate some of the mundane tasks that we do on a day-to-day basis so that human errors can be eliminated to the far significant extent. With the data that we get from all these different devices, we also want the capability to take real-time actions as if it's a human being. So looking at the trends, looking at the patterns, we want to optimize certain things. We want to enhance the workflow processes. So these are things which come as a part of the benefits or the goals of an IoT system. And finally, of course, all of us want to have devices, vehicles, infrastructure at a cost which is affordable at the same time without compromising on services and products. So in the upcoming slides, we'll see how each of these goals are being satisfied in the IoT segment, especially for the automotive. So what exactly is automotive IoT? So this image that I have shown here is basically taking the Internet of Things and combining it with the automobile infra. So when I say automobile infra, it's a car and the car electronics, where I'm showing the car electronics with an IC, which basically means there are a lot of microcontrollers and microprocessing systems inside, which take the car's sensor data and they send this data either to the vehicles, which are, say, connected vehicles, or they send this information to the passenger, the driver inside, or receive information from them. It also connects to navigation systems. It could connect to the smart infrastructures around, so the traffic lights or the smart lights, street lights. Using all this information, it's processing something, it's sending something to the cloud. Some things are happening on the car's vehicle engine unit, and that information is eventually helping us enhance the safety of the passengers, making the travel more safer. There's more reliability of the vehicle infrastructure as a whole. So when you are talking of the uptime of the vehicle, the operational efficiency of the vehicle, those things get improved. And finally, it's all about enhancing the user experience in terms of what we'll talk about connected cars, fleet management, telematics, and we'll go into details of how each of this is helping us define what today's luxury travel is all about. So as we move inside, there are three main circles which I have highlighted here: the intelligence, the things, and the network, which overlap to what we call as IoT. So here, when I say things meaning they are all the sensors, all kinds of sensors, cameras, lidar, radar, all that you could imagine. Those, let's call them as things. When you connect these things over the network to a cloud setup or to any sort of processing engine, we basically build connected device. Now, if you have these sensors which have some sort of processing capability to take decisions, and then if you look at it as a combination of things and intelligence, it's basically becoming a smart device. And if you're applying the data that you're collecting on the network and applying intelligence to it, so when I say intelligence, we are talking of AI and ML, and that's where you start getting enabling the smart services. And when you combine all these three together, that's where the IoT becomes a popular choice in redefining how we are looking at it from different use cases. So automotive IoT is nothing but a subset of this IoT segment, but specialized for automotive applications. So smart mobility, connected cars, vehicle to vehicle interactions, vehicle to infrastructure interactions. So those are things which will fall under this segment. Similarly, in IoT, we are talking about the sensors, the things with intelligence, which means we are talking about computing data and processing it at the node level, the end node level. So what end node is, I'll talk about it in the upcoming slides, but it's about doing things faster without having the latency of being able to send the data to the cloud, getting it processed, getting the data back into the vehicle system. So those things add latency. So that needs to be choice of what you want to process at what part of the segment in the entire IoT infrastructure. And that's all which combines devices, sensors, vehicle, and cloud, and to combine them all and provide a good, rich user experiences about automotive IoT. So before we get into dive deep into all of these sectors, the use cases, this is a quick slide to tell you what all IoT could do. So right from driver management, fleet management, software updates, updating the cars, ECU engine software, monitoring the drivers, driving conditions as health conditions, connectivity between vehicles to that are plying on the road. So one vehicle can talk to the another vehicle. So the real examples that are out in the market today, I'll give you those examples as well. And of course, telematics and the very popular Tesla thing and the BYD thing that's going around with autonomous vehicles and a lot of intelligence going into ADAS and stuff like that. So all that comes from the automotive IoT domain. So let's take a quick look at if we are to compare what this traditional IoT is about and comparing that with the automotive IoT. Traditional IoT is all about connecting different devices, automating them, and making them scalable. And here everything comes under the traditional IoT segment, whereas the automotive IoT is very specific to transportation as a use case and vehicles as a use case. In terms of connectivity, again, both, if you're looking at it as wired and wireless, it's the same. But the type of protocols and the ruggedness of the protocols, again, differ between the two segments. Applications, of course, traditional IoT is very broad-based, and this is going to be very specific to cars and mobility. Challenges, again, are very different between the two sectors. Privacy, of course, is one of the key factors which is common to both, but other than privacy, there's also interoperability issues are one of the challenges. Hacking is one of the biggest threat that we have today in the IoT space. In terms of communication types, it's all the same. It's vehicle to vehicle, and on the traditional IoT, it is more about device to device, device to cloud. And for data sources, again, you collect data from different infrastructure in case of traditional IoT, while in the automotive IoT is all about collecting data from within the vehicle and putting it on the cloud and using data from other vehicles and combining them at the server side. In terms of latency, your data has to be real fast in terms of processing, taking quick actions on the automotive IoT side, while on the traditional IoT, it's not that stringent. Of course, if you're looking at robotics in the automotive manufacturing sector, there you need immediate actions, but I'm just talking about very traditional IoT. Again, the environment conditions, traditional IoT could be more a controlled environment where the temperatures don't really have to go to that high extent. Whereas in case of automotive, it's going to be really stringent, harsh temperatures. We're talking of -40, we are talking of +120 degrees C, huge amount of vibrations, a lot of humidity, depending on the locations where these automotive vehicles are going to be used. So those are some of the key things when you compare between the two segments. So if you look at broadly the IoT architecture as a whole, it's all about sensors, end nodes, all that inside a vehicle, which we'll represent on the left side by this block. So the lights, the engine system, all the automation that goes around inside the automotive. This data needs to be pulled over the network. So when I say network, it's the car network. It could be the engine mechanics, which has to talk to different sensors and fire up some things, or it could be the windows, it could be the safety system. So there are different protocols that are used in this area. And this network will eventually power up storing this data for further processing. Either it could happen inside the vehicle itself, or a part of the data is processed inside the vehicle and some are sent back to the cloud. And eventually, those are where our automotive applications come in, where we talk about predictive maintenance. We are talking about, say, applications like telematics. We're talking about connected cars, getting navigational alerts, route management systems. So those are different types of applications. So broadly, if I have to categorize in blocks, this is what an IoT architecture would look like for an automotive space. And now if we take a sneak peek into what exactly is inside the vehicle, this is how you could broadly categorize them into few blocks. So you have a few sensors, some memory units to store the data locally, controlling the motors, actuators, and all this block somewhere it's going to process data inside the controller, do some onboard AI ML engine to process something. For example, the natural language processing needs some sort of AI ML engine to process whatever we speak to the car dashboard, and it interprets that to give voice commands to control, say, the doors, windows, the sunroof, moonroof, so on. We also, some might have touch screen buttons if then that is interactive with the passenger. Some units will not have a touch screen, so there are local processing happening, which will be fed back to the server on the automotive side. For example, Blue Link on the Hyundai motors, or may the Suzuki Connect, for example. So all that mobile apps that show you data about your vehicle parameters, your driving, the way you drive, your speeds, if there was a sudden braking, all those things, that data shows up because these data are being sent over the cloud using these different modules in the automotive block. So if you look broadly in terms of the vehicle communication, there are so many different things happening inside the vehicle. So gone are those days where you had to crank the machine in the engine to get it started, to what today we have a touch button, or maybe you can even speak to the car and it just starts up. It knows that you're near to the car and it will automatically start the car engines. So those are things that have advanced in this sector, and all that has been possible because of different things that are happening inside the instrument cluster, inside the TCU, basically the telematics control unit, the engine ECU, different things happening with all the interactions that are happening with different sensors inside the car and sending it to the cloud or passing information via the mobile devices and so on. So this is a quick peek of what all happens inside the car. We'll go further into the details of each one. Now coming to how AI and ML is making a significant impact in the IoT. So why do we actually need AI and ML is where the slide is going to talk of. So in terms, as per the statistics, if you go by this market, especially in automotive intelligence market, will be growing to around 74.5 billion US dollars by 2030. And as you maybe already hearing all the news that happens, Mahindra SUV, I don't know how many have you followed this Mahindra 6E, which has this automated parking where the driver can come outside, use his tab, and you can automatically control its parking abilities, and it would go and self-park itself. So those are things which already happen because of the AI ML algorithms that run inside them. But first, let's understand what is AI and how different it is from ML, because both are two different terminologies, although everybody uses them as a AI/ML. So AI is all about automating the actions based on the data the car sends to certain processing unit. So if you want to automate something, instead of you doing it as a driver, that's where the AI algorithm comes in place. For example, automatic braking, for example. So let's take an example of ADAS where it judges the distance with the car that's on the front or on the rear, and then it knows that if it's within a certain distance, it's going to automatically brake. So that is the AI part of it. But when you want to apply ML for a part of it, that's where the other feature of ADAS comes in, where it is going to follow the speed of the car that's going in front of it. And depending on how fast or how slow it moves, it's going to adjust the cruise control on it. So that is the ML part of it. So this is where the ML comes in, where it learns something based on the past data from the past trend, and it's going to apply that. Similar is the case with terms of making personalized recommendations, for example. So it knows who is going to use the car at that point in time. What kind of song choices are you playing in your car if it's day or if you're traveling in the evening? And accordingly, it's going to interact with certain apps to try and get you your mood choice of music or video streaming, so on for the passenger. So it's basically enriching the experience using these capabilities. Another example is basically custom language. So example, it will, if you're able to talk to your car's dashboard in your native language, and imagine it's able to understand your native language, and it's controlling your sunroof, it's controlling your car ignition, you're able to stream, you're able to talk to the car dashboard. So those are all the ML capabilities where it continuously learns from the abilities, and then it kind of suggests what needs to be done. Similar is the case with the route optimizations. In terms of traffic management, it will have the ability to talk to the street lights and let you know if there is a ambulance that's coming. So it will the ambulance will interact with the street lights, and there'll be a special blinking pattern on the street light using which you can give way to the ambulance. So these are real use cases that are available in Europe, and now it's slowly also transitioning to Indian space. Similar is the case with examples such as using the density of traffic at a certain traffic point. The cars can interact with the traffic light, and that information will be used intelligently by the traffic signal control system, so that you're not stopping on a certain red light for long hours or for long minutes if there is not too much of traffic around. So intelligently the traffic management happens. So those are capabilities which get built in with the AI and ML algorithms. And those are fed back into. So this basic block diagram is all about how the data is continuously churned between the vehicle infrastructure and the processing system to build something which makes a lot of user intelligence. So I'll just skip this slide. It's basically talking about the same thing that I just spoke. And now let's take a look at the market growth of IoT. It has been growing year on year by roughly say 20 to 30%. Starting in 2022, when the trends really started picking up, it was around a market of $102 billion. And it's expected that by around 2032, this market is going to be $800, almost like a 400% jump. So this is the potential of what automotive is today. And one of the significant areas where automotive is really kickstarting is the investments that's happening inside this trend, with different companies jumping in with so the amount of investment that has happened in the vehicle technology in terms of software enabled vehicles is actually around $740 billion for the year 2024. And we are just in somewhere we are talking about, this is the revenue scale that we are talking of. So I think there's a lot of market movements happening in this segment, and slowly companies in the automotive segment have started using software as an enabler to make a huge leap in the software sales approach when it comes to automotive. So today, when you go as a buyer, you are not just looking at the features of the car, you're also talking about what extra abilities the car can do, what things can we do in terms of connecting our gadgets to it. And that's where software enabled automotive industry is getting a big jump in terms of technology advancements. And when we talk about the trends in the automotive segment, I made this block where we are talking of three different areas where the entire ecosystem is benefiting from these trends. Let's talk about the manufacturer benefit. So it's about when they apply IoT techniques to manufacturing, they are able to enable smart manufacturing. What smart manufacturing is about customizing a vehicle as per your needs. So if you are looking at custom functionalities, custom features, they need a custom inventory to be managed, which so that they can make a just-in-time inventory management system, and they don't have to really block their capital trying to hold up a lot of things. And with so much rapid change in technology, they new models coming in year on year, it won't be really feasible for them to build a huge list of inventory. And at the same time, they cannot hold on customers with 6 months and 9 months of delivery time, which you would have already seen during the COVID, after the post-COVID times. So to do some quick deliveries, to manage the inventory, these are areas where manufacturer wants to enable efficiency using IoT technologies. And that helps him to reduce the overall overhead cost, and it helps him to stay competitive. Now, when we look at the service providers where they use IoT to make sure they're able to manage their fleet efficiently, there are no downtimes, there is a good amount of predictive maintenance that are happening. So the amount of service quality, the service SLAs, those things are managed very well in terms of the IoT being brought into automotive. So, what is your regular last mile delivery going to be, and how many routes do you have to do in one day for a delivery? If there are any issues with the vehicle, if there are any driver abilities which are causing losses to the company in terms of fast driving or in terms of accelerating the vehicle and braking too much. So those sort of fleet management parameters are being automated and put into the system to make some meaningful information out of it. And that's one of the services that I'm trying to target in the service provider benefits from the IoT. For the customer, it's more about improved driving safety. It's more about being able to do more with the car's automotive system, dashboard systems, being able to stream music, stream video, talk to the vehicle to do controls. And then you don't really are dependent on taking your car to the service center to get your engine updates, to get your vehicle OT updates. Those are being done remotely, and that's also helping the manufacturers to manage effectively their service center usage, the floor space usage. And for the customer, it's easy because he's not having to take out time to get his car to the service center. A lot of things get automated by the OT updates. So a lot of fixes that keep coming because of the glitches in the system, say battery charging system, or for the engine ECU, these things get immediately fixed, whether it's braking, whether it's any of those safety parameters. So this trend is kind of helping the entire ecosystem, ranging from manufacturers to service providers to the customers. So now that we have an overview of how automotive has redefined the automotive space in IoT, using IoT, we'll talk about more into how this happens on the automotive vehicle infrastructure. A lot of IoTs that we have been talking from a software centric has been more towards taking the data to the cloud, having some sort of a GPU to process the data and bring that data with some sort of intelligence. And that's something which we can't do with the automotive infra, because a lot of things have to be done very fast. It has to be real time. And that is where edge computing comes in place. So if I have to break down the entire IoT architecture into several computing methodologies, then it would be edge, fog, on-premise, hybrid, and cloud. So edge is about doing things on the edge. As the name says, it's on the vehicle infra. So the sensor itself has the capability to take in the data, process the data, and make some decisions. So that's edge computing. Fog computing is basically a level between on-premise and edge, where the data is collected from the sensors. Some decisions the sensors take, and some of the data is passed on to a gateway. For example, let's say you have a vehicle with a TCU, a telematics control unit. You have the vehicle, so the car's dashboard, it's getting data from the TCU processor. It's getting data from the engine ECU. It's getting data from the mirrors, from the doors, from the sunroof, from the braking system, from the ABS. and it's computing all this data. Some data gets processed on the car's dashboard computer, and it's able to send back certain alerts. It's able to take some corrective actions. And some of the data which need not require immediate processing is sent back to the cloud. It could be any of the cloud that the manufacturer has on his end. So that is where telematics data will come back to your mobile applications. You'll be able to see in my last 1 hour drive, what was my speed, what was my mileage, what was my fuel efficiency. So those sort of processing need not happen real time. So that data goes to the cloud and you get it on your mobile. So those are things that happen in the fog computing domain. The on-premise computing is about when you take your car to the service center, they want to check your engine parameters, and that needs to happen instantaneously. And there are some things that they want to check on the server and get the statistics. So they connect a OBD interface to your car. It scans all your data. It sends the data. That data goes to the on-premise server on this in the service station. They use that data to make changes to your car configuration. They use the data to process their inventory to make sure what component goes bad too often, what components need replacements after a certain period of time. So that data is used on the on-premise service, which does not need to go to the manufacturer. The hybrid computing is basically somewhere in between the service center and the manufacturer. So if you're going for placing a new car order, you want to customize a few things. So those pre-sales aspects are managed in a hybrid computing format. And the cloud computing is where a lot of things happen on the cloud. So I'll just skip that part. So edge computing is what is the key thing in AIoT, where it helps you to reduce the latency, it helps you to bring in reliability, it helps to enhance data security, because you don't have to really send data somewhere outside. It's all within the vehicle unit. So the cost is less. You don't need to employ a cryptography IC. So you're saving cost on it. You are really not bothered about how the data is going to be hacked and all that. So those are some of the advantages by doing the computing on the edge side. In terms of connectivity, when we talk of AIoT, it's the pretty much standard connectivity that we all know. It's Wi-Fi, BLE, and now even NFC has started to make good prominence in the IoT segment. So like, for example, the key fob, it has an NFC technology, or you could use your phone to, for example, Hyundai Alcazar has this new feature that they have introduced where you could use your cell phone and you can open up the doors without a key, and that happens via NFC. All the car dashboard that gives you the navigation parameters, integration with either Map My India or Google Maps or any custom maps that you are integrating with your car system, those happen via the cellular networks, which give you data connectivity. The dedicated short range communication, which we call as DSRC, is a communication connectivity methodology that is used to connect between different cars. So there are two cars going on the road, and if you're going too near to one of the cars, then the car itself will talk to the other car's engine ECU, and the brakes are regulated, the steering movements are regulated. So those are technologies where you need to really have a very fast communication, which is more fast and reliable. So those things happen with the short range communication, where the data bandwidth is not going to be too high, but it needs to be really fast. Similar is one such communication, which is called ultra wideband communication, UWB. This is also a communication methodology which is used with the key fobs. So as soon as you walk near the car, it detects that the driver, the valid owner of that car has come nearby, and that is when it unlocks the doors. That is when it detects that the car is near to the car's key, and so it will allow you to start the ignition. So those technologies are enabled by ultra wideband communication. In terms of the connectivity protocols, the protocols used to talk internally inside the car with different sensors, different ECU, TCU units, those are where you use the control area network. It's basically called the CAN bus. It's more rugged. It's a differential protocol, differential signal protocol for ruggedness in terms of noise and all that. The mechanical, electrical interfaces, those have to be rugged. So those noise that generate from these interfaces, those have to be isolated. So that's where the CAN comes in. Local interconnect network is a is actually a lower cost version of a CAN bus, but again, it's used for controlling your mirror movements. It's used for connecting your control system from your dashboard to say the mirrors or the sunroofs. So that's where LIN is used. FlexRay is another protocol which is used for very high deterministic communication. So it could be like talking to the brakes of the system. So when the ABS has to be activated and there's some, if you have the engine ECS, ESC and the ABS, which when they have to interact, those happen over the FlexRay. The automotive Ethernet is basically your dashboard connecting to the camera, the 360-degree camera. So which is where you don't rely on Wi-Fi, but you rely on an Ethernet mechanism because there is a huge bandwidth of data that needs to be transferred, which you can see on your dashboard, the clarity of the camera. So those things are achieved with automotive Ethernet. CAN FD is again a variant of CAN bus, but for flexible data rates. Media-oriented system transport is another protocol which is used for streaming videos from your gadgets, from your devices, cellular phones, from your tabs into the engines of your car's dashboard. So you can see your videos real time. You could have all those sort of multimedia capabilities. And in addition to that, we also have communication standards, which are generally used in IoT, where you need secure VPN connection between your vehicle and the cloud and the manufacturer cloud or the manufacturer server. These connections have to be encrypted. They go through a TLS mechanism, TLS 2.0, and so advanced protocols, so that the data cannot be hacked. They cannot be snooped inside. This slide basically talks about the difference of Wi-Fi, Bluetooth, what's their capability in terms of range and the data speed. So this is just a quick glance at when we talk of cellular, we are talking of today, we are talking of 5G and why it's getting more popular for the kind of bandwidth it gets you, for the kind of range it gets you. Um, and when it comes to say Bluetooth, Wi-Fi, what's the range it would be effective? Because we are talking of theoretical ranges which say as 10 meters, but when you're actually employing these technologies, the range will definitely reduce. So this is just a quick review of the capabilities of each of those connectivity standards. I wanted to take a moment to talk about 5G since a lot of things are happening today on 5G, and 5G has a good amount of popularity in IoT because of its speed. So there's very little latency, almost zero, especially when you're talking of getting things back and forth between the cloud and the vehicle. It has a huge bandwidth, so a lot of things can be done fast and like video streaming, real time talking over a video call, for example, or in a moving vehicle. So those are capabilities of a 5G. You can virtualize the network, which means you can make network slices. So you could have dedicated networks. Thereby, it's like a VPN network. So you could have a one VPN network you can have for certain internal car communication. You could have another VPN network, which is just the interaction between the cars, passengers, and the manufacturer, or between the service providers like the RSA, roadside assistance. So those sort of secured communication can be established in 5G. It's all software based, which means a lot of things can be enabled in the 5G using software tech. It's a low cost. Now it's, although the price seems to be costlier than 4G, but eventually this will enable getting us at a very low cost data rates. There's a huge support that's available that's building around this ecosystem that supports 5G. And lastly, it's about battery usage because there's very finite battery that we are talking of when we talk in the vehicle infrastructure. And if your vehicle is parked for several days and it's not being utilized, and if you have all the electronics that's trying to interact and there are so many wireless connectivity, so everything is getting powered. So you need to make sure that it doesn't drain the batteries that frequently. So that's also one of the reasons why 5G is getting popular because it consumes very less battery as compared to the technology like 2G. And that's the reason why 5G is getting so popular in today's next generation cellular connectivity. Now let's look into the real use cases where IoT will make a significant stride over how these things will help enrich user experience. So telematics. Telematics is all about monitoring the vehicle parameters, vehicle position, location in real time, getting information about, for example, if as a passenger, if I'm going to look at my mobile phone and I want to find all the nearby taxis, these capabilities are built because of the telematics that comes from the car's engine. There's a OBD data that goes to the server from the service center or from your car. So it tells you if there are certain things not happening in the right order, in the right process, if your vehicle is being accelerated too fast, and if you're applying brakes too frequently, then it's going to give you alerts about your fuel consumption. It's going to get you position of your vehicle, the speed, and it's going to interact with the maps and tell you what is the quickest route, if there is traffic congestion, if you need to take alternate routes. It's also going to monitor all your parameters inside. So if you're on a long journey, if you do not want your vehicle to undergo any breakdown, it's going to get you all those parameters, which helps you to take quick actions. So this is all about telematics, and this happens because of the telematic unit that sits inside your car. It's taking all the information over the canvas. It's getting some of the data processed, and you see some alerts on your dashboard. And some of this data also travels through your dashboard to the car cloud servers. For example, if you have seen BlueLink, for example, if you have seen Suzuki Connect, so some of these parameters are already available on your mobile app. You could watch your what days, what you have speed you have traveled, which locations you have traveled. So all those information are available in the telematics because of the telematics feature. So it benefits in terms of efficiency. It helps you to improve safety. It minimizes the operating cost. Costly repairs can be done away with. It offers a good, superior driver UX and UI environment entertainment system, because you have good amount of controls that shows alerts. It tells you what needs to be done. You don't have to worry about if the car is going to break down if you're on a long journey, whether it's cargo transportation, passenger transportation, whether it's commercial transports, and so on. It enhances the security by ensuring that whatever parameters are being monitored, it's kind of safely sent through certain parameters which should not be messed up. For example, which are very specific to the engine control unit, those parameters will be secured inside the engine. Those parameters will be just sent, but you cannot configure them remotely. So those are things which are the benefits of having telematics unit and their intelligence. The next use case that we will talk about is fleet management. So, for example, Amazon deliveries or Zepto, for example, or any deliveries for that matter, you have a lot of ecosystems that's built around. You have to manage different vehicles, the allotment of the vehicles to different drivers, the license management, driver licenses, vehicle licenses, road taxes, the fuel consumptions, if they violated any traffic rules, if there are any accidents, any incidents that happened, if there are any maintenance issues, or if there have been any spare parts that are changed. So it's basically a complete ERP system for managing a fleet of vehicles to ensure everything is managed on time. There is good amount of logistics that's getting managed without excessive overhead cost. It's efficiently managed. So those things are possible because of the IoT being applied. And that helps you to improve processes, increase productivity. It ensures safety of your goods being transported. It makes sure the drivers are effectively driving the vehicles. They're not overspeeding. They're not, there's no reckless driving happening. So that those all things help to, at the end, enhance customer satisfaction, make sure their service quality is good, and all this happens at a competitive cost. So these are one of the biggest advantage of fleet management system, which comes as a result of IoT integration. Sorry. The third use case, which is very popular these days, is ADAS. ADAS is basically Advanced Driver Assistance System. And this is basically using radar, cameras, ultrasonics, and the vehicle data, which are all put together to define different types of safety mechanisms that are built into the car. So the 360 degree camera is one example where it gets you the data. It shows you, it enables you to park safely, uh, navigate your cars in tight corners without colliding with other things around. It helps you to park your car properly. It gives you lane alerts. If you're changing lanes, it's going to alert you. Cross traffic alerts are possible. It's even has the capability to read the road signs and tell you if you are over speeding, if you're traveling too slow on a certain road where you need to maintain minimum speeds. So those are all ADAS features which are which can give you these sort of details because of the IoT data integration with the sensors inside the car. Um, the capabilities of ADAS are again quite huge. So there are primarily 5 levels of ADAS. Um, from level 0 to level 5. The level 5 is something that we are yet to see as on date. There are talks in the US where Tesla is experimenting level 5, but as on date there are no such level 5 capabilities as yet, which can be completely relied on. But first, let's understand what are these levels. Level 0 is the basic automation where the automation is not by the system, by the processor, but it is about giving you information to the human for him to drive safely and take some actions, corrective actions. For example, the reverse camera, the ultrasonic reversing sensors, the blind spot alerts that you see on the mirrors. So these are basically just indications that something is not right or you need to take corrective actions, but the system itself won't take that action. The driver will have to read these inputs and then accordingly take his actions. So that is why it says no driving automation. So everything is indicated, alerted, and the user has to take charge of it. The level 1 ADAS, the ADAS 1 as we call it as, it's basically driver assistance level. This is where you have adaptive cruise control. So you can set your say cruise speed and it will follow that speed as long as you don't press the brakes. It won't do it automatically, but you'll have to set something and it will automatically take up for some duration and then it's on the driver to regulate it. So that is level 1 kind of ADAS. Level 2 ADAS is what we are prominently seeing these days in most cars like the Hyundai Tucson, Mahindra SUV700, MG Globster, MG Aster. It's about lane assist, reading the traffic signals. To a certain extent, it's automating it, but it's again not completely automatic. You still need driver intervention. So it's not that you put the car in ADAS 2 and then you leave the car steering, how you see on certain YouTube videos. That's not really complete automation. If you lose the signals, if you lose the detection capability, then these systems won't really have the intelligence to take corrective actions. So if, for example, the lane assist, if you do not have those white markings on the road, then the radar will not be able to detect those sort of signals, especially the depth and all that, because it works alongside with the camera, which detects your white markings on the sides. And along with the radar, this sort of information will not work if those things are not available. And that is why it becomes partial driving automation. The level 3 address is basically conditional driving automation, which is generally seen in Mercedes Drive Pilot as an example where they have applied this. Audi A8L is another such vehicle where we have ADAS 2 features along with level 3. So level 3 is about it will be able to automatically move the vehicle without the driver's intervention in, say, a traffic jam, for example. So where you have to slowly look at the traffic ahead, slowly release your brake, clutch, you move a little ahead, then you stop, you have to apply the brakes. So those things are automated in the level 3. So it's kind of a conditional driving automation where you can leave the steering aside and it will do on its own. The level 4 is basically the autonomous vehicles that we are seeing as on date. It could be a golf cart, which is automated inside the Infosys premises, for example. It just sit inside and it takes you through. It's conditional, yet it's driving automation, but they are all geo-fenced. So which means they have to be programmed in terms of what are the fixed obstacles. So they know they wouldn't really take that path. So they're not completely free running. At the same time, they have capabilities to understand what kind of objects are in front of them. So they will be able to detect the objects. They'll be able to differentiate the objects. They will be able to find out how soon I should be braking, or how earlier I should be braking before the object is detected. So those sort of capabilities come under the level 4 system, the level 4 ADAS. And the level 5 ADAS is all about the sci-fi thing where it's completely driverless. You sit inside, just key in your geographical coordinates, and it'll take you through the entire traffic, no matter how the traffic dynamics are, whether it's predictable, unpredictable. The computer has full control, and there is literally no driver needed. And that's the level 5 ADAS. So these are still in research phase. There is no such guarantee as on date that it would go without any accidents. There are still glitches around. But broadly speaking, ADAS is categorized into these 6 levels, level 0 to level 5. Then next use case is predictive maintenance. So when we talk of vehicle maintenance, there are two types of maintenance that come in play. One is preventive and the other is predictive. All preventive maintenance about that every 6 months your service center would give you that after so many kilometers you should come to the service center and get your service vehicle serviced, get your engine fluids changed and so on. So that is basically that's what we call as preventive maintenance. But preventive maintenance does not guarantee that something is probably okay even after the service has happened, because there are only restricted amount of parameters that can be measured and monitored by the vehicle's OBD system. If the sensor is going to fail eventually, it's not going to tell you its health in an OBD system unless the sensor itself has the intelligence. And that is where predictive maintenance comes in, where there's a separate control system which is going to do a self check on the vehicle every time you start the ignition of the system. The vehicle's engine system has a separate control unit on it which senses all the sensors parameters. It makes sure the parameters of the sensors are within a certain temperature range. The decisions are happening within the bounds of certain values that have been configured by the factory. So those parameters are used to make sure what is the regular wear and tear of certain usage of the certain engine parts, the engine control systems, and so on. And that is where predictive maintenance comes in, because the data that these sensors collect needs to be sent out somewhere for somebody to use that data and interpret it, to monitor it, and analyze if certain sensor is going to go bad soon. Maybe after 2 months, the sensor is going to go bad. So if you are being alerted, then you know that you can plan your journeys, you can plan your car services, and so on. So it helps you to predict vehicle faults. It helps you to take corrective actions in advance, thereby reducing the cost, thereby reducing your downtimes. And it also optimizes the spare part inventories for the service center. So it doesn't happen that you go to a service center, they say part be aaya nahi hai, this part is not available. You'll have to wait for a few days so that we can replace it. So all those issues can be resolved with the predictive maintenance, because it's already telling the service center what part could go wrong. It will tell the users what could happen, and thereby it enhances the safety in a way and make sure that there is good amount of operatable time rather than downtime, and make sure there are less warranty claims, and those sort of benefits are available in the predictive maintenance use case. And this again makes it possible because of the IoT being there, which gets you all the data as and when needed and from the different systems and gets it processed. The fourth use case that we are talking about is connected cars. This is where ADAS comes in to a certain extent. And of course, beyond ADAS, there's also many things that we will talk about in the connected cars. So this gets split into 4 main sections. The first section is vehicle to vehicle interaction. So this capability has not been seen in the Indian cars so far, but there are quite some cars out in the international market which have these capabilities. So if there's a car traveling which is kind of very close to your blind spot area, or if a certain car is going at a certain speed and is coming quite near to it during the merge intersections and so on, the other car, one of the cars will kind of interact and it will reduce the engine speed without the driver having to do it. So the driver would probably be pressing the accelerator pedal, but the engine mechanics, the EC unit is not going to allow the car to speed up. Thereby, it avoids collision, thereby it avoids prevents an accident. So those sort of interactions are basically vehicle to vehicle. To give you an example, the headlights that you see, so if, for example, in the SUV 700, you have this headlight beam control. So if there is a car that's coming from the other side, and if it's on high beam, and if this car is on the high beam as well, then the high beam of this vehicle will switch to low beam. Thereby, it's not blinding the driver. So those are also examples of vehicle to vehicle information exchange. This is a very basic example, but this goes really complex when we are talking of engine issues of one car talking to the engine issue of the other car. The other such connected car use case is vehicle to infrastructure. Uh, like I was saying in the very beginning slides, the vehicle can talk to traffic lights, can talk to toll booths, can talk to street lights, thereby giving you alerting system, thereby giving you capability to steer on a toll booth without having to queue up on a certain junction. So the density of traffic can be easily managed if those infrastructure and the vehicles can communicate with one another. And that's the technology that we are talking of in the vehicle to infrastructure segment. Vehicle to pedestrians is basically, imagine having a mobile app and you're trying to scan the vehicles around. So as on date, what we generally are habituated is to look at the app. The app communicates with the third-party service providers. They get the data from the vehicles and thereby you locate the nearby vehicles. But there are capabilities inside the car that's getting built where you don't really need a third-party system. So it's like a nearby scanning. Use your mobile app and you can scan all the taxis that are around you. So taxi brand A, taxi brand 2, taxi brand 3, all three taxis, you don't really need their custom apps, but you can still go ahead and look at in your app and locate these taxis. When you take a taxi, you can already estimate what's the travel time going to be by keying in your destination. So basically all those sort of things are what comes under the vehicle to pedestrian use case. And the fourth is basically vehicle to network. Uh, Vehicle to network is about speaking to the dashboard, getting the weather forecast before you travel on an upcoming journey, taking notes about what are the roadblocks that are there so that you could take an alternate route optimizations, fastest route, toll less route. So there's so many use cases that are possible. Similarly, you can talk to the engine dashboard. You could talk to the infotainment system and ask it to play music of your choice from the app that is of your choice. For example, Spotify, it could be YouTube, it could be a custom app on your mobile. So those capabilities come from the vehicle to network infrastructure. So whatever audio you speak, it is able to personalize you. It knows you that you are the individual. So in case if you and your wife are traveling together and it's programmed such that it has to only hear your voice, you have those sort of capabilities which can be built in. That is ML that goes behind, which recognizes your voice. It's voice activated and it will take your voice, interpret, do some local processing, get you something which is instantaneous real time. And in some cases, if it's about getting the forecast, it's going to send your voice processed data to the server, say for example, weather station, weather.com channel, for example, it's going to get you the weather for your destination, wherever you are traveling to. So those are things that happen in the vehicle to network domain. The other example of vehicle to network is in terms of getting you health parameters of the driver, the telematics basically, where it tells you if you are driving fast, if you're driving not so alertly, which means it will give you some sort of indication, an alert on your system, so that if the driver has some sluggishness or if he has improper rhythm of his heartbeats, those things can be detected by the car and give you some sort of alerts to prevent an accident. So those all come under the use case called vehicle to network. The connected infotainment systems, as we all know, in most cars today, we are talking of all these smart computers, sort of, where you can control your dual AC climate control ACs. You can stream your Apple CarPlay or your Android Auto. You could talk to it. You have your integration with the maps. You have control systems that will tell you vehicle diagnostics on it, the maintenance, service reminder. So you don't really have to figure out when to take your car to the next station. You have on your rear view mirror that's set on your front towards the driver with buttons on it with the RSA roadside assistance or a blue link button, for example. So you can press the button and you will get connectivity with the service center or with a human who could assist you in case of roadside breakdown if you need any towing services. So all those capabilities are possible because of the connected infotainment systems which interact with a third-party server, with a third-party service provider, and it helps you to enhance your travel experience. Similar is the case with integration with turning on the engine with your voice commands or locking up the windows, taking care of ensuring that you have enough warnings available on your dashboard so you can drive safely. So those are all advantages and features of the connected infotainment systems which come as a part of the IoT integration. Now let's talk about the challenges and opportunities in the IoT market. So when we talk of data, all about IoT data, one of the significant part of the data being collected causes also threats in terms of being vulnerable to cyber security threats, hacking, data breach. What kind of data is being collected from you? Many people don't even know what's being collected from them. They are quite enthusiastic about sharing everything that they want. So you share your biometrics, you share your health parameters, your driving patterns, the locations you visit, the time of your travel. And if this information is so sensitive that if it gets into the wrong hands, you can be traced, you can be kidnapped. You can imagine so many different things could go wrong when this information is not used in the right way. Similarly, data is being transmitted from the vehicles to manufacturers, to service stations, to third parties. So you don't want to have targeted advertisements happening. So if you are somebody who really doesn't want to get bothered with all the marketings that are going around, you want to be careful about what data is being sent. Is it being sent with your consent? Because there are a lot of privacy data laws prevalent in all different countries. You have to respect those stuff. So even though you need data to make intelligent decisions to enhance customer experience, but there's also a certain limitation in terms of how much data you could use. There's also consent to data that you need to ask legally for a customer to share that with all these use cases. So those things have to be kept in mind when we talk of data security and privacy concerns. To give you an example, Nissan Leaf is basically from Nissan, who had a kind of feature which would heat the steering wheel for cold climate so that it's comfortable as soon as you enter the car. And there was also comfortably setting your air condition remotely. There was a bug inside this entire system which allowed an unauthorized access to controlling this in a remote from a remote setup. So imagine if I have this sort of a bug, some sort of hacking that happens. Imagine your car getting immobilized because the complete battery drains off and you are traveling somewhere, and if such a thing happens, you are kind of stuck in the middle of nowhere. So those are things which have to be taken care when you are connecting data from your car infra to the cloud and taking it back, because there are so many people involved in this entire ecosystem. So you'll have to be really, really careful of what you share and how you are going to process it when you as an automotive engineer are offering these services. So for securing data and to ensure privacy, make sure you have enough security chipsets put in place so that the data is protected, encrypted, regulated. When you're collecting data, make sure the data is being collected for the absolute purpose of what it's being done. It's not for selling data to third party to make money out of it, because you want to do custom personalizations, you want to give targeted ads. So you'll have to be very careful when you're using data for those such use cases. It has to be very secure, you're encrypted. You have to allow adjusting the privacy of what the customer wants to share. You'll have to make sure the password abilities are quite robust, because passwords, you probably ask a customer to key in a password and, for example, a dash cam, for example, or maybe something on your car's entertainment system, and you are trying to key your password and it's as simple as 1234. And which means, for example, in Bluetooth, if you're going to give that simple a password, it's going to result in blue snarfing, where you could take over the car's control system via a backdoor entry, or you could, of course, blue jacking is not really that risky, but you could also blue jack some of the systems inside, and kind of these things have to be avoided. And similar is the case with NFCs and RFID based techs. So you don't want the cars to have all these advanced tech and become theft prone. So those are things that we have to take care of, and always make sure to update your car's software, whether it's your engine infra software, or is it, if it's the infotainment software, all that needs to be kept updated. All the security loopholes that come as a result of your third-party operating systems that are running inside the car's infotainment system, those security patches have to be applied on time. So those are not leading to any sort of risk, because passengers are going to connect their mobile phones, they are going to connect their tabs with your infra on the vehicle. The next challenge is about interoperability. Like we already know, in the EV space, every car has its own custom charging requirements, the custom charging infra. Similarly, when you're talking about cars, infotainment system, sharing data with the cloud, one brand can't talk to the other brand. These things have a lot of problems when you are talking of fragmented standards, because there's no standardized IoT platform. So if you're moving from one brand to the other brand, your data is possibly not going to move. So if you are somebody who wants your data, telematics data, to be moved from one platform, one car brand platform to the other, it's all today a big challenge, because there's no universal standards or no universal interconnect platforms available. Each vendor has its own. And those are big challenges when you have technology versatility coming into the IoT space, especially in automotive. Similarly, you have Android versions coming up, Apple versions coming up. Your phones have to support different versions of Android, which today is very rare. Maximum 3 versions of Android are supported. But cars, imagine that lifespan is like 5 years, 10 years. So if your features are being introduced, which is more software centric, you also have to make sure there's good amount of interoperability and compatibility for various versions that you want to support. Otherwise, it's a very costly device if you can't support all these features and still go into the market saying that we are very software centric and we have a lot of features. So these things are one of the key challenges today that this market is facing. Now, the regular typical AIoT challenges that if you look at, it's about long deployment time. There's a lot of time it takes to build systems because of non-uniform standards, because of different frameworks, different protocols. So it's taking time to deploy things and making it robust. Softwares will have its bug, making sure that they are safe enough. Those things will take time. Network stability is always a challenge. So it's not guaranteed that a cellular network will be available in all spaces wherever the car travels. So if you have to take decisions locally, what decisions have to be processed on the vehicle's infra, what decisions have to be processed on the cloud, those things have to be nicely managed and architect. So that's where unstable networks and connection bottlenecks have to be managed. Similarly, your choice of protocol to have interaction between the sensors of the car also has a very significant role in terms of latency control, in terms of real timeness, and so on. And now today, automotive is more about software centric, more of software features which are enabling car sales, which means you need a lot of IoT experts who are needed in the market, who could understand not just the software part of it, but understand the firmware, understand the hardware behind it, use your right tech stacks to make sure there's meaningful data being utilized to enable sales and to enable customer experience. So this is again a very big challenge when it comes to getting the right sort of skill sets in the automotive segment, especially because automotive is now becoming more software centric. If you've heard about Bosch, there are companies which are trying to slowly move from being pure automotive to becoming automotive plus software. So today, car sales is primarily driven by what software features are being built into it. Intelligence, AI, autonomous operations becoming a de facto need to increase the car sales, to meet competition requirements, and to make sure they're all efficient and cost effective. So these are some of the typical challenges that we are seeing in today's IoT industry. AIoT industry. In terms of expansions and innovation exploration opportunities, I think a lot of things are happening at the device level, vehicle level, infra level. The data is being shared at several touch points, at several third-party sites to build systems and solutions which have meaningful impact on the overall ecosystem. Real-time data analysis, again, what kind of data you want to analyze, what is the monetization ability of having this data being sent to the customer. For example, BlueLink is sold today with a 3-year license, and after that you need to enable. But for a customer to pay for a service like that, it has to be meaningful. It has to be useful to enhance the customer experience. So those are areas which are also seeing a good amount of expansion. Type of notifications, how can you reduce your downtimes? How can you make sure your travel times are very efficient? Making sure that your car has minimum repairs, making sure that you have as much you can get out of your car for the cost that today we pay. So those are all collectively giving rise to the future opportunities that today we have in the automotive space. And a quick look at some of the companies which have been doing real great work in using IoT in the automotive space. For example, everybody knows Tesla Motors, their autonomous driving experience and what they're trying to build in. Ford Motors has IoT-based solutions in the name of Go Drive, Go Park, Ford Pass. So basically, Go Drive is basically the automotive driving experience of allowing it to self-drive itself, to park itself. Go Park is a similar such technology. BMW has an IoT-based solution which connects to its platform called Connected Drive Services with IFTTT. So it's basically to get you vehicle performance at an optimal level. So those are things which happen out of these platforms. Our Mahindra, an Indian company which has this platform called DigiSense. It's a connected vehicle platform which connects to different Mahindra vehicles, tractors, trucks, construction equipments, especially for a leasing industry. So if you want to lease tractors for agriculture, or so this sort of platforms enable which vehicles are available. So you don't really want to have to go and buy these vehicles. You could get them, lease them for a certain duration, utilize it, and then you can give it back. So those are enablers of IoT in the automotive space that Mahindra has enabled. Smart Shift is another tech for fleet management that Mahindra has provided for all its cargo owners and transporters. SYOUI is a platform that helps you to make some pre-purchase decisions. For example, what kind of features you need in your car, what you want to customize in your car, what could be the type of inventory that might be needed to provide personalized customer features. So those platforms are again from Mahindra, which they help to manage not just the user experience, but also to manage the manufacturing timelines and inventory timelines and so on. Tata Motors has a platform by the name Tether. It's a connected vehicle platform for tracking real-time movement of their vehicles, finding out all the EV charging stations available en route, monitoring the EV vehicles battery parameters, making sure it's not getting too hot, it's getting charged properly. If it's being constantly charged on a fast charging cycle, then for the health of the battery, it will also enforce slow charging cycles. So those are different technologies which are enabled by these platforms. So these are some of the happening things in today's environment in the automotive, with all these companies offering these technologies. And finally, the last session, but not the least, the lessons that we have to learn is, as they say, data is gold because everything happens with data and everything also happens with data, intended, because if you lose data, that can be a significant risk. So with data comes a lot of responsibility. If you're collecting data and not doing anything about it, it's a lot of money wastage because you're spending server space on the cloud and it's costly indeed. Um, to make anything smart, you need data. And when you collect data, it has to be relevant. It has to have a direct purpose of what you want to do with the data so that you are not increasing the burden of the entire system as a whole, but also giving effective advantages of using it. If you're building AI, ML capabilities, data has to be taken in responsibly. You want to be ethical about how you're using this data to control your systems. So it has to be done in a responsible, ethical way. IoT business is all about varied skill sets, varied technology stacks. So a good understanding of what will work and what will not, because all these vehicles have a lifespan of 10 to 15 years that they need to be supported. So you have to have a right choice of what you're going to bring on the tech stack level. And finally, data security and privacy is the most important part. A company can be sued by if they don't follow certain country laws, and it can even go to bankruptcy if that happens. Imagine the number of scale of cars that are being sold today by each of the manufacturers. So these are things that we need to keep in mind. These are the lessons that we have to learn out of what could happen from an IoT space, traditional, what happened in a traditional IoT space, and how these things have to be carefully protected and put up in a commercial environment. So these things have to be taken into account. Yeah, so this is all I had for all of you guys. Hope you had a good informative session. So now I'm open for your Q&A session.
Thanks, Rohit. There are a few questions in the chat window.
Yeah, sure.
Would you like me to read it?
Yeah, I have the questions. Yes. I think the first question is from Mohammed Kaif Khan. Your question is, are SDVs similar to IoT cars? I didn't get that SDVs. So what exactly, maybe if you can type that in your chat, I will eventually answer that question. The second question is from Venkateshwaran. IoT as a technology would be key driver in software-defined vehicles. Yes, indeed. What
SDVs
frequency
are
band?
software-defined vehicles. I was just trying to explain it to Mohammed. So
Okay. Okay. Yeah. So when we say software-defined vehicles, basically, uh, I don't get that term. What SDVs we are trying to put it. So there's nothing like IoT cars. It's basically cars which have intelligence because of the IoT infra in place. A lot of things can be automated. So I don't really know what that SDV means.
yes,
So
Mr.
there's this
Rohit.
question.
Sorry to interrupt.
Yeah.
Yeah. In
Yeah.
essence, it's an emerging field of it's an emerging automotive field, and IoT would be a key technology driver rather than being separate IoT cars. Not sure about Mohammed's question either, but IoT would be one of the key technology drivers there.
Correct. Yes. So that's a question from Ritushri. What frequency band can be used to make a level 5 autonomous car? And our other question is, what will be the role of IoT in that case? So there's no one unique frequency band that we are talking of when we talk of level 5 autonomous cars. We are talking of ADAS level 5. So there are different sensors that are employed in an ADAS. It's LiDAR, for example. There are ultrasonic sensors. There are cameras. There are different sensor feeds that go in. So it's not one GSM band or there's no one wireless frequency that we are talking of. It's a collective use of sensor data to process that intelligence inside the vehicle for the vehicle to take action. So you don't need a driver to intervene. Rather, the computer in the car will take the decisions as if it were a human. So that is what it means when I say level 5 ADAS. Your other question is, what will be the role of IoT in that case? So So I would, in general, for all kind of ADAS, from say from level 1 onwards, as soon as the data is being transmitted outside your car's infra to something which is third party, it could be a server where you're processing the data. It's all about IoT. It's like the things, the sensors which are taking in data, taking some decisions, and then sharing a few of the data which is for on the gateway level or at the cloud level. So that's all about IoT. So you're basically pushing data from the vehicle infra to the cloud using some sort of wireless or a wired medium. And the two data that's available on the two sides of the continent, they together help you take decision. That's IoT about, and that's where intelligence comes in. Uh, there's this question from Amit Kumar. When data transfer to cloud, it is done by hashing function, or there's no process in raw data directly transferred? No, raw data is not transferred. It's all secured. So there's a cryptographic chip that is used. So there's a custom white noise. If you're from an electronics background, you might have heard about it. There's white noise. That's used to encrypt the data. There are several such cryptographic technologies available. Hashing is something that is used for passwords and stuff like that. So whatever passwords that you set in your car that cannot be seen by the service station, somebody in the backend or at the manufacturer. So there are hashing used for securing passwords, but the rest of the data that goes from your vehicle to the infra or to the cloud, those are not sent raw. They're always encrypted. And that is why I said that's very important. If somebody is doing that, then it's something that they have to seriously intervene. You cannot send raw data that way. Your second question is, when data transfers on cloud, any cyber security checks are followed? Basically, yes, all cyber security related protocols have to be followed. You cannot get them hacked. It should be hacking proof. It should be, you cannot be able to spoof into the data. So it has to be really secure, because there are some data which allow the factories to configure your car, limit the acceleration speed, for example. So those are data that can be easily tweaked. And if that happens in a very unsecure way, then you can literally cause accidents. By a hacker could cause that on the vehicle. So definitely there are a lot of such cybersecurity checks done. There are security audits also done. So it's when a car is getting designed with all the software-centric modules on it, it also goes through an independent security audit. There are specialized people who do these certifications, and that's how the data is secured. The third question is, if no tower or internet available, then can telematics hold data in remote areas? So again, so when there's no tower or internet, no, you can't have data being transferred. But these data is not completely relied on third-party servers. Some telematics data gets post-processed. So the data is collected. Some are shown on the vehicle's dashboard. Some are collected in the internal memory of your infotainment system or the car's dashboard electronics. And whenever the data connectivity happens, or whenever it goes into a data connectivity region, that time the data is pushed into the cloud processes it, and then you see the data on your mobile phone or on the servers of the service providers. So telematics does not need the data to be available real time all the time. So it's not that critical either. Hope I am able to answer your question, Amit. Again, Ritoshi's question, what type of antennas are being used in level 4 ADAS? Again, it's not just, we are not just talking of any wireless mechanism alone. So LiDAR, we have ultrasonics, you have, so there are different types of technologies that go into ADAS levels. You have camera. So for example, camera does not have any sort of antenna. So you're not transmitting the live feed of a dash cam, or for example, you are not transmitting your 360 camera feed to anywhere on the server. So there are no such antennas as such. So it's not about thinking it as an RF. It's about collective usage of sensors which do some sort of processing within the car. It's all about real-time decision making. Only the post-processing thing happens. So for example, if your dash cam video has an event, for example, an accident event has been captured, it's all going to be locally stored in the dash cam that's inside the car. whenever there is connectivity with your mobile phone or through an hotspot, for example, Wi-Fi hotspot, or if you're having some sort of subscription with your manufacturer. So whenever that connectivity happens, it will send the data once it's kind of parked or once it's kind of stationary, when the vehicle is more stationary in a certain section where there's good amount of tower connectivity. So it's a mix of many things. So it's not just dependent on one such antenna to answer your question. What is the difference between ADAS level 2 and 2 plus? Amit's question. So basically, level 2 allows you to have partial automation, and level 2 plus allows you to have conditional automation. So there's a two. So the difference is, let's take example of ADAS level 2, like a lane assist, for example. So or a cruise control, for example. So if you key in your speed that you want to travel at 70 kilometer per hour in level 2, you will key in that speed. And if a vehicle in front of you has gone to say, has slowed down a bit, so it's gone to 65, the vehicle that has ADAS level 2 will also manipulate its speed to 65. So it will maintain a speed relative to the vehicle in front of it. And when there is sufficient distance available, then it will again recalibrate its speed to whatever you have set to 70. So that's partial automation. In level 2 plus, what really happens is it has all these capabilities, but it will also have additional capability of you can just leave your steering wheel and you can kind of, even if it's having an emergency brake, it will apply the brakes, it will slow down. It will kind of have a little amount of conditional automation on it. So you can still leave your steering confidently and ensure that you're not getting into an accident sort of. So 2 and 2 plus has this conditional automation thing. So that's the difference. Your second question is, what is the relationship of battery aging via normal charging and fast charging? Yeah. So basically, when we are talking of the car battery technology, it's about lithium ion, lithium polymer, just like how you would see on your mobile phones. There are two types of charging that's available in the EV space. One is the normal charging, or what we call as slow charging. The other is called the fast charging. In the fast charging technology, the current is quite huge. It's also called as DC charging, where you have a very high amount of current being pushed into the battery system. Of course, there's a battery electronics that manages it, but that allows you to charge your car at a faster rate. So probably your car will get charged to 60% level in 2 hours. So if you're going somewhere quickly outside, you want to do that on a fast charging. But fast charging also degrades the battery performance, the battery life. So if you're going to all the time do fast charging, then it's going to impact the battery's lifespan. So these EV systems have the intelligence in them to know how many fast chargings are being done in a certain routine, and then it will force a normal charging. So if you use this in a combination, then it enhances the battery life. Aruvi's question is, what's the difference between ADAS and SDV? Again,
Mr. Rohit,
yeah,
in the interest of time, can we take up one last question?
yeah, sure. Which one would you like me to take?
It's up to you, Mr. Rohit, whichever one is most relevant.
There's this question from Biju. His question is, what is the decision maker for selection of protocols and devices for features? For example, why camera for front and rear parking, and why not radar? So there are two answers to this question. So the decision making for selecting the protocol depends on what is the latency, what is the bandwidth of communication that you're expecting. So for example, DSRC, the one that I spoke about for vehicle to vehicle communication, those are very restricted in terms of bandwidth, the amount of message that you could transfer between the two information exchange systems, but it has to be really fast. It has to be deterministic. So that's the way you make your choice of protocol. CAN systems are again very elaborate, quite expensive to implement as compared to LIN. So this is how you make your choices. Your other question was why camera for front and rear parking and why not radar? Again, camera technology and radar technology are two different things. In some cases, for example, radar will also work in different weather conditions, while camera will not work if the lighting condition is not very good. So if you are having ADAS systems which are camera controlled, then there is a high possibility that it won't be that robust when you are going in a, say, heavily raining condition, or if it's too dark. In those scenarios, ADAS will fail in a camera controlled one, while a radar will work with no issues in all these sort of different climatic conditions. Yeah, I think those are the list of questions I've been able to take up.
Thank you, Mr. Rohit. We'll deal with these questions offline. Thank you, everybody,
Sure.
for joining in. Thanks once
Thank you,
again, Mr.
everyone.
Rohit.
Thank you.
Folks, we will just drop the recording of the session on YouTube and share you the link. Meanwhile, please take up a couple of minutes and fill the feedback form that is available on the chat window. Thanks, everybody.